In last lecture, we understood the concept of theories of failure, and we understood why theory of failure is required, because we want to predict the failure of material under a complex state of stress. Since we don't know which component of stress, okay, in complex state of stress, we should compare it with our material strength. Okay, that is not very clear, and that is the reason we have theory of failure. Okay, maximum shear stress theory, which is also called Tresca theory. It is one of two popular theories of failure for ductile materials. So this theory states that the maximum shear stress at a point in a material when it exceeds the shear strength of material in a uniaxial tensile test. Okay. So let's see this one first. Shear stress, maximum shear stress in uniaxial test. We know sigma 2 equal to sigma 3 equal to 0 in uniaxial tensile test, and sigma 1 is equal to yield stress. So maximum shear stress for uniaxial case is equal to sigma 1 minus sigma 2 or sigma 3 by 2, and that's how we get sigma y by 2. So this is right hand side, sigma y by 2, and maximum shear stress for complex or triaxial state of stress is given by max of three shear stresses. Okay, maximum shear stresses. We know the state of stress is described by three principal stresses, and we get three maximum shear stresses from three principal stresses. So these are three maximum shear stresses. Now the three principal stresses are in decreasing order. That means sigma 1 is greater than sigma 2 is greater than sigma 3. But the difference we don't know which one is largest. Okay, and therefore we need to take the maximum of three max principal stresses. No, let's try to understand this with a simple example. Let's say sigma 1 is equal to 50 megapascal, sigma 2 is equal to say 40, and sigma 3, let's take it is equal to 10. Now sigma 1 minus sigma 2, this difference is 30. Sigma 2, this is not 30, this is 10. Sigma 2 minus sigma 3 is 30, and sigma 1 minus sigma 3 is 40. So here no, it is, we cannot we don't know which one is the largest. Okay, in this case sigma 1 minus sigma 3 is the largest. So this is the largest shear stress, and this we need to compare with our sigma y. Okay, and since it is not known, okay, we have to take maximum of three shear stresses, maximum of three maximum shear stresses, to compare it with our yield strength or material strength from the uniaxial tensile test. And why absolute? Because the maximum shear stress can be positive or negative. Okay, this can be positive or negative. Now, unlike in normal component of stresses, no, which is tensile and compressive, we say tensile is positive and compressive is negative. Okay, this similar logic does not apply to shear components, because whether it's positive or negative shear strain stresses, they both result in change in angle. Okay, whether the positive shear strain results in decrease in angle, and negative shear strain results in increase in angle. Uh, so whether it's positive or negative, okay, both are causing the change of shape or distortion of shape. So that is the reason we need to take whichever, whether negative or positive, whichever is larger. Okay, we have to take that for our Tresca criterion, and that is the reason we have absolute difference. Okay, absolute value of the difference. Okay, now let's see, try to understand Tresca in a graphics, okay, or visually. So this is a visual presentation of Tresca yield surface, but for 2D case. Okay. So sigma 3 equal to 0. We have just substituted here sigma 3 equal to 0, and this is our Tresca yield surface. Okay. So let's try to understand this. Here we have three component of maximum shear stresses. So we can say sigma. We can say sigma 1, okay, is equal to sigma y, which means sigma 1 equal to sigma y and sigma 1 equal to minus sigma y. Similarly, sigma 2 is equal to sigma y and sigma 2 equal to minus sigma y. Similarly, this one component, sigma 1 minus sigma 2 equal to sigma y, and sigma 1 minus sigma 2 equal to minus sigma y. So, okay, so we have six lines here. Okay, this one is sigma 1 equal to sigma y. This is sigma 1 equal to minus sigma y. This straight line, these two straight lines. Then this line is sigma 2 is equal to sigma y. This straight line is sigma 2 is equal to minus sigma y. And these two lines, okay, these are these two lines. Okay, so this line is sigma 1 minus sigma 2 is equal to sigma y, whereas this line is sigma 1 minus sigma 2 is equal to minus sigma y. Now with this, no, this, if you see this hexagon, okay, this one is enclosed by all these six lines. Okay, so this uh, surface becomes our Tresca yield surface. And in a material, at a point in a material, if stress state is anywhere in this within this surface, this is a safe region. Okay, and the stress in a material, if it is outside this surface, okay, we call it is a failure of material. So in next lecture we will see one message theory.